estimating with percents. Estimating with percents is going to be something that you are going to hopefully find incredibly useful, not only in math class, but in your life from now on. I can tell you it's very useful for me all the time, and I'm hoping that it does the same for you. So I'm going to try to get this across to you in a way that hopefully is rather painless. In front of you, you can see I have common percents and their fraction equivalents. In my opinion, these are percents that match up with fractions that you should know the value of automatically. If you don't know them yet, just start thinking about them more frequently, and you're not going to have any problem with that. For example, 10% is equivalent to 1/10. 20% is equivalent to 1/5 of a whole. 25% is equivalent to 1/4. 33 1/3% is equivalent to 1/3. If you divide 1 by 3, see I said divide by 3, that's also another way to help you with this. If you divide 1 by 3, it's going to be 0.33333, and it's going to look like it's 3 forever on your calculator if you were to do it that way. Well, that's because 0.3 repeating represents 1/3. When you divide 1 by 3, you're always going to have that remainder. Always, 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 always. So that's why. 50% is equivalent to 1/2, and 66 2/3% is equivalent to 2/3. The reason is, when you divide 2 by 3, you get 0.66666666 repeating. Sometimes you'll see a 7 on the end of your calculator, and that's there because your calculator rounds it because it runs out of room. But in fact, there's actually no 7 there. It's just 6s forever. What I have here is divide by. This is just a memory tool. If you wanted to find 10% of a number, you would divide by 10, and that would be 10%. If you wanted to find 20%, you would divide by 5. If you wanted to find 66 2/3%, you would want to find 1/3 first, then multiply by 2. So you would divide by 3, then times 2. It's a little note I have there for you. We use these common percents to help us estimate the percent of an amount. So we're going to work a lot with estimating, and I really want you to keep in mind that an exact right answer is not what I'm looking for. I'm interested to know that you estimate in a way that makes sense. So you're allowed to move the numbers around a little bit, either of them, in order to get a nearly accurate amount. So if you were to estimate the price of something, or estimate the time it would take you to get somewhere, you wouldn't say, I think it'll take me approximately 3 hours, 23 minutes, and 59 seconds to walk somewhere. You would say, you know, an hour and a half, probably 23 minutes, close to a half hour, and that's fine. So keep that in mind when you're estimating throughout this lesson, that you're not going to have exact answers, because that's not what we're looking for. So if I'm looking to estimate 48% of 79, 48% is very close to 50%. And 79 is an ugly number. It's pretty much 80. If you're talking the price of something, $79, you would probably say $80. So that's what we're going to be going with. And 50% of 80, well, you can think about that as half, here's 50%, half of 80, and half of 80 is 40. So we know that 48% of 79 is going to be approximately, and that's this squiggly equal sign here, approximately 40. Is it going to be exactly 40? No. Sometimes will our estimate be an exact answer? Actually, yes. But we're not worried about that. 40 is a really good answer for an estimate here. So when will you ever estimate with percents? The answer most of the time is going to be shopping. Okay, you're going to estimate all the time, and so I want you to think about this. Jacob wants to purchase an Xbox 360 at GameStop. He notices that it is on sale for 20% off. If the original price of the Xbox 360 is $249.99, how much will he be asked to pay? And I say before tax, because I don't want you to worry about adding on another percentage here. So 20% off. Okay, well, if your Xbox 360 is $249.99, how much do you think that it is? $250, right? So I'm just going to think about it being $250. And then it's on sale for 20% off. On the previous board, I said 20% is like 1/5, right? So if you divide by 5, you're gonna find out what that 20% is. So I'm gonna say 250 divided by 5, and that's going to be $50. $50, now it's 20% off. Is the Xbox gonna be $50? If it was 80% off, it would cost $50, but it's 20% off. This 50 is 20% of the $250. So if that's the 20% and it's 20% off, we need to subtract $50 from the original price, which we estimated to be $250. So 250 minus 50, that's $200. Not a bad deal for an Xbox 360, I'd have to say. So then we come across another way to estimate, also known as my mom's method. My mom, when we would go shopping, she would tell me, how much is it? Or ask me, and I would say, I don't know, well, go figure it out. And I was like, okay, you got it. So she taught me a way to figure out percent off of something that was much easier than typing in a calculator or working out this massive algorithm. Basically, if you know 10%, you can do anything. So if something's 20% off, or 25% off, or 30% off, you can figure out exactly how much off that is and then subtract it away and find out what you need. So to find out 10% of any number, you're going to divide that number by 10. And I can just tell you that and you can believe me, or I can show you why. And that's because we talked earlier that 10% is equivalent to 1/10. So for example, 10% of 20 would be equivalent to saying 1/10 of 20. And when we find 1/10 of 20, we multiply 1/10 times 20. That comes across, without any simplification, as 20/10. We simplify by dividing by 1 to get 2 over 1, which we know is 2. And we can more quickly and efficiently get to if we divide that 20 by 10. So I found 10% of 20 more quickly by saying 20 divided by 10, and that is 2. Okay? So how might this work? And this is very realistic here. At American Eagle, denim is on sale for 30% off. The tab price on the jeans you cannot live without is $64.99. How much will you tell your mom they cost to have the best chance of owning them? Right? If you walk up to your mom in American Eagle and say, I have to have these jeans, they're $65. Are you kidding? $65 for a pair of jeans? They made of gold. I don't think so. So they better be on sale. And the best chance to get a really cool pair of jeans is to tell your mom that they're actually not that expensive, right? So how can we figure this out in our head without pulling out our cell phone, in order to really work through it? Challenge yourselves. It's fun when you figure it out and then you get to the register and it comes up to be really close to that number. That's why estimating is so much fun. 30%, which is what the sale is 10% times 3. So if you find 10% and multiply by 3, then you know what 30% is. So the first thing you're going to do is find 10% of the cost. $64.99 is not my favorite number to work with. Lots of digits, decimal points going on. So I'm just going to round that to $65. I'm going to say, okay, I'm starting with $65 here. I'm going to find 10% by dividing 65 by 10. That's going to come out to be $6.50. So 10% of $65 is $6.50. Now I'm going to multiply that by 3 because I'm taking 30% off, not just 10% off. So if I multiply that by 3, and actually I like to estimate this in my head. So let's think, $6.50 times 3. Well, $6.50 times 2, that's $13. So I have to add another $6.50 on. That's going to be $19.50. But $19.50 is like 20, right? So I'm going to say, well, that's like $20 off. Approximately $20 off. It's quick for me to subtract 20 from 65, right? $45. So 65 minus 20 is $45. Now you can say, hey mom, these jeans, they were $65 and I have to have them, but they're actually $45 on sale. They might not be on sale tomorrow, right? So $45 on sale. And I applaud you for using your mathematics skills in American Eagle. Oh, there we go. So sometimes you might need to find a percentage of something that's not as easy to work with 10%. Most of the time you will be able to use 10%. You're not going to go into stores where something's 2% off or 3% off. But you may come across some math problems where you're working with smaller percentages. So this method also works with 1%. So if you were ever asked to find 4% of a number, the 10% method might not help. You could get it to work, and we'll talk about something like that here in a second. But to find 1% of a number, you simply divide that number by 100. We found 10% of a number, we divided by 10. To find 1% of a number, we divide by 100, and here's why. A number is 100% of itself. Any number, like 400, 400 is 100% of 400. If we take 100% and divide by 100, we get 1%. So 1% of 400 is like saying 400 divided by 100, which is 4. So 4 is 1% of 400. Make sense? Yeah. So let's do some practice using these methods. If we were to estimate to find 27% of 63, 27% is not really close to any of our 10%, but it is really close to 25%. And 25% is something that is very simple to work with because you simply divide by 4. 25%, 1/4, 1/4, all of those connections you can make. And I don't particularly like 63 either. 60 is a much rounder number to work with. Now, if I'm looking for 25% of 60, all I have to do is divide 60 by 4. That is not a challenging task. In fact, it comes out to be 15. And 15, because we are estimating, is a brilliant answer here. Quick, easy, done. Estimate to find. We've got 4 quick problems here. And what I want you to think about is my solution reasonable? And I'll talk to you about how to figure that out here. If I'm finding 29% of 80, 29% is close to 30%. So we're going to use our 10% method. I want you to think 30%. So how do I find 30%? Well, if I find 10% first, then I can go anywhere with it. And I remember that 10% times 3 is 30%. So first of all, to get 10% of 80, I divide by 10. Let's do that in my head. 80 divided by 10 is 8. Now that's 10%. So I can say 10% is 8. Well, that means 30% is 8 times 3, which is about 24. And so 29% of 80 is about 24. Perfect, acceptable estimation. Number 2 here, 4% of 18. Okay, this is going to be a time when you might have to use that 1% method. And to find 1%, you divide the number by 100. Well, if we divide 18 by 100, that's going to look like this. We could actually say 18 divided by 100, that's 18 hundredths, right? And another way to represent 18 hundredths is as a decimal. There we go. That is 1% of 18. Now to get 4%, we just multiply by 4. So 18 hundredths is kind of ugly. I would actually rather work with 20 hundredths, which is like 2/10, and then multiply that by 4. That's going to get me to 80 hundredths or 8/10. And this is a wonderful estimation. Okay? 39% of 19. How would you change it? You're allowed to change it a little bit. Remember, we're estimating. How does 40% of 20 sound? Yeah, way better, right? So let's find 10% of 20 first. We do that by dividing by 10. 10% of 20 is 2. And then 10% times 4 gives me 40%. So if 10% of 20 is 2, then I multiply that by 4 to get that 8 is about 40% of 20. So 8 is 39% of 19. Remember, it's an estimation. It doesn't have to be exact. The answer is 8 there. How about 5% of 82? This is where you could use either the 1% method, divide by 100, or the 10% method. And let me show you how that works. I'm going to change this to 80 because 82 is kind of silly to work with. What's 10% of 80? You get 10% of 80 by dividing by 10. So 10% is equal to 8, right? So if 10% is 8, how do you get 5% if you know 10%? Divide it by 2. So if I know 10% is 8, then that means 5% of 80 is about 4. And absolutely, I would accept 4 as an answer here. Wonderful work. And that's it. Estimating with percents.